Hello everyone, my name is Gulbarsin Mukasheva, PhD Senior Teacher of the Department Epidemiology and Biostatistics. Today I am going to present a lecture on the topic correlation and regression analysis. Correlation is a type of relationship in which each specific value of one variable corresponds to several possible values of another related variable. For example, the relationship between a person's height and body weight, or between body temperature and pulse rate, etc. Correlation coefficient divided into three groups. If R is more than 0, positive correlation. If R is less than 0, negative correlation. If R is equal to 0, no correlation. Correlation parameters. A measure that describes the direction and strength of the relationship between variables. The correlation coefficient provides an understanding of the direction and strength of the relationship between two variables or phenomena. Its range of variation is from 0 to +1. Correlation parameters. Form of correlation: linear and nonlinear. Direction of correlation: direct, positive and negative. Strength of relationship: strong, from 0.7 to 1, moderate, from 0.3 to 0.7, weak, from 0 to 0.3. In this slide you can see graphical presentation of correlation coefficient. If R is equal to 1, it's strong correlation. In this picture you can see how it will look. If R is 0, here you can't see any line. Here no any line, so no any correlation. If R is -1, here you can see a line but looking to another side. If R is 0.3, here you can notice some line but not correctly. It's looking like 0. If R is 0.6, dots along the line, not towards the line. If R is 0.9, here dots close to line. If the parametric and non-parametric correlation analysis, we should understand if that is quantitative or ordinal. If quantitative, are the variable normally distributed? If yes, we will use Pearson's coefficient. If variable are not normally distributed, then we will use Spearman's coefficient. If data are ordinal, then we will also use Spearman's coefficient. The Pearson's coefficient measures the linear relationship between two continuous variables. Here formula of Pearson's correlation. Here shown interpretation. Conditions for using Spearman's correlation. The data are not normally distributed. The variables are measured on an ordinal scale. The relationship is nonlinear but monotonic. For example, as one variable increases, the other consistently increases or decreases. Here you can see formula of Spearman's correlation. Regression analysis. Regression analysis determines the relationships between variables using various statistical models. It allows one variable to be explained or predicted based on one or more other variables. Types of regression analysis. Simple linear regression. For example, does weekly working time affect employers' hourly wages? This model examines the effect of one independent variable, working time, on one dependent variable, hourly wage. Multiple linear regression. Do weekly working hours and employers' age affect the hourly wage? This model examines the effect of two or more independent variables, working hours and age, on one dependent variable, hourly wage. Logistic regression. Do weekly working hours and employers' age affect their likelihood of burnout? Here you can see types of regression analysis on the table. In simple linear regression analysis, you can see only quantitative variables, only two variables, independent and dependent. Multiple linear regression, here quantitative and quantitative, but many here. Logistic regression, here we can use not only quantitative, ordinal and nominal variables also. Here you can see pictures. For better understanding, if you look these pictures, you will understand differences of this regression analysis. Regression is used to model of effect of one or more independent variables on a dependent variable. Linear regression describes linear relationship between an independent variable and an independent variable. Here you can see formula. Multiple regression, a type of linear regression that includes several independent variables. Here also shown formula. Logistic regression is used for a dependent variable that is divided into two or more categories. It models probably using a logistic function. Coefficient of determination. The main indicator of the quality of regression analysis is the coefficient of determination, R square. The coefficient of determination shows that proportion of the variable y is explained by the model and reflects the influence produced by the factors included in the analysis. The value of R square range from 0 to 1. If R square more than 0.8, the regression equation is considered of high quality. The coefficient of determination is equal to the square of the correlation coefficient, that is here shown formula. Assumptions of linear regression. There must be a linear relationship between the dependent and independent variables. The error term must be normally distributed. There should be no multicollinearity, and the regression coefficients should be stable. There should be no heteroscedasticity. The variance of residuals should remain constant across predicted values. Linearity. In linear regression, a straight line is placed through the data. This straight line should represent all the points as accurately as possible. If the relation is nonlinear, this straight line cannot fulfill this requirement. Here you can see linear and nonlinear pictures. What is logistic regression? Logistic regression can be used to predict dichotomous variables. It estimates the probability of the occurrence of a certain characteristics, that is, the presence of a feature. In medicine, for example, the goal is often to determine which variables influence the occurrence of a disease. In this case, 0 may represent not diseased and 1 may represent diseased. And the effects of factors such as age, gender, and smoking on the disease are analyzed. In this case, medical example, 0 may indicate not sick and 1 is sick, and factors such as age, gender, and smoking are examined for their effect on the disease. Why not just use linear regression? Infinitive values. As can be seen from the graph, the values in linear regression can range from negative infinity to positive infinity. Estimating probability. The purpose of logistic regression is not to predict the exact value of a variable, but to estimate the probability of an event occurring. Limited range. The predicted values are limited to the range between 0 and 2. Thank you for your attention.